When a substance changes its state, heat energy is involved. The energy is not to heat up the substance, but to separate the molecules from each other. This is known as specific latent heat. Specific latent heat should not be confused with specific heat capacity. Before watching this video, I recommend watching this one first. Specific latent heat is defined as the amount of heat required to change 1 kilogram of a substance from one physical state to another without any change in temperature. So specific latent heat is the heat energy absorbed or given out when a substance undergoes a state change. For example, the heat energy absorbed when a candle burns and a solid wax melts. Two key things to note. Firstly, that specific latent heat is particular to state changes, so the specific latent heat to change ice to water is different to the specific latent heat to change water to water vapor. And secondly, that there is no change in temperature during this change of state. It remains constant. The temperature will only change once the state change has completed. As I said before, the heat energy is not used to heat up the substance, hence no change in temperature, but instead used to make or break the bonds that hold the molecules together. If we heat up a plastic fork to its melting point, see between points B and C on this graph. The heat energy it absorbs at its melting point is busy breaking the bonds between the individual plastic molecules. Once enough bonds between molecules have been broken, the fork will melt and become liquid plastic. Messy. After this point, if we keep heating up the melted plastic, a temperature rise will be detected. The temperature will keep rising up until the next state change, liquid to gas. At the vaporization point, the plastic would stop increasing in temperature whilst it transitioned to gaseous plastic. Once in the gas state, if we were to continue heating further, the gaseous plastic would, you've guessed it, rise in temperature. So breaking bonds is why the temperature does not rise or fall when a substance undergoes a state change. Remember I said earlier that it may take a different amount of heat energy to change a solid into a liquid than to change a liquid into a gas? For example, it takes 7 times more energy to turn liquid water into gaseous water than it does to melt ice into liquid water. This means a substance can have 2 specific latent heats. Now let's have a look at the maths. To calculate specific latent heat, we use this equation. This formula can be rearranged. The units of specific latent heat are joules over kilograms. Let's do a practice problem. Remember that specific latent heat of fusion is the energy required to make water to go from liquid from solid. Pause the video and attempt the problem before pressing play to see the answer. Did you get it right? That's a lot of heat energy. We could turn it into kilojoules by dividing by 1000. So in summary, specific latent heat is the heat energy transferred between 1 kilogram of a substance and its surroundings when it undergoes a change in state. There is no change in temperature, and we calculate it using this equation.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.